Good afternoon, everyone.
Good afternoon.
Good afternoon, teacher.
Good
How are you
afternoon.
today?
I'm good, thanks.
I'm good.
I'm cool, thanks.
Okay, so our subject for today is science. We will continue our topic about electricity or its electric.
Part 2. Today.
So our subtopic for today will be electrical conductors and insulators, series and parallel circuits, and electromagnetism. So we have three. Now let's start with electrical conductors and insulators.
คนนำไฟฟ้ากับไม่นำไฟฟ้าเหรอ
Yes. Okay, who wants to read this one?
Me. Not me.
Okay, see
Not
game.
me.
See game. Come on.
Insulators do not allow electric current to flow through them.
Okay, very good. So insulators usually are made of wood. What is wood?
ไม้
Okay, wood.
ไม้
Okay, the next one.
ไม้
The next one. What is this? How do we read this word?
พลาสติก
Okay, plastic.
พลาสติก
Next,
paper
paper. Very good.
ปะ
Paper.
ปะ paper
Next word.
ceramic
Ceramic. Yes. Okay.
something that I don't
This is okay. And the last one is
rubber
rubber. Okay. What other examples of insulators do you know? Aside from these things. Glass. Okay, glass. What else? Mr. Black Panther. Aside from glass,
don't
what
know.
else? How about fabric, clothes? Does electricity flow through clothes or fabric?
no
metal
No. No, it's not metal. We are talking about insulators. Electricity cannot travel. So let's go with conductors. Who wants to read this one? Bua, thank you.
me
Okay, Blue Day. Let's give the mic.
conductors
Uh-huh.
they allow electric current to flow through them.
Okay, thank you so
Well.
much. Who wants to, Bua, can you read the second sentence?
electrical conductors are usually made of metal such as
Okay, thank you so much. The first kind of metal is? How do we read this word? Okay, iron. Do you know the symbol for iron?
Iron Man.
Okay.
Iron
In the
Man.
periodic table, the symbol for iron is Fe. Next,
SUS. Copper.
copper. Okay, copper.
Copper.
Have you seen copper before?
Yeah, in the wire.
Okay, from wires, electrical wires. Very good. Next,
steel
steel. Okay,
Steel cullet
okay. And
is bad.
what's the last one?
Aluminium.
Okay. Have you seen like this before?
Yes.
Okay, aluminum foil. So who wants to read the first sentence?
Me.
Okay, Kiki.
electrical conductors and insulators are chosen to make different parts of an electrical component.
Okay, thank you so much. Next sentence, please. Max.
The wires in a circuit are made of electrical conductors such as copper. This allows the wires to conduct electricity.
Okay, thank you so much. Next, who wants to read this one?
Me.
Okay, Blue Day.
The covering of the wire is made of plastic. The plastic covering does not allow electric current to flow through it, it and hence it protects the user from electric shock.
Okay, thank you so much. So here is an example of an electrical wire. So the inner part is made of metal, usually copper, and outside is usually made of plastic or rubber.
Rubber.
Yes. So what if it's the opposite? The plastic or rubber is inside and the covering will be metal or yes, metal. What do you think will happen? What do you think will happen if it's the opposite way?
Electric shock.
Okay. The user will have electric shocks. So, can you identify other example of electrical conductors and electrical insulators? Okay, give me example first of electrical conductors. Things that can conduct electricity or where electricity can flow through them. Give me things or objects that can conduct electricity. Come on, example. Example for me is metal ruler. What else?
Metal spoon.
Spoon. Okay, metal spoon. Any other example? More? Okay, any object or things that made of metal can conduct electricity. How
Okay.
about insulators? Electrical insulators.
Table.
Plastic ruler.
Plastic ruler. I see.
Table.
What kind of table?
Eraser. Wood table.
Wooden table. Okay, yes.
Eraser.
Eraser. Very good.
Cardboard.
Okay, made of paper. So let's continue with series and parallel circuit. So here is an example of a simple circuit. Who wants to read the first sentence? Let's give chance to Jenny. Please read the first sentence.
The brightness of bulb
Mhm.
in an electric circuit depends on the amount of current current flowing through it.
Okay, thank you. Next sentence. Sun. When?
ออมสินหญิงทำไรอ่ะ
San, can you hear? We cannot hear San. Okay, let's call on Tigger.
Okay. When more current flows through the bulb,
Wow.
the bulb lights up more brightly.
Okay, thank you so much. And the last sentence. Wants to read? Heal. Can you please read the last sentence?
When less current flow toward the bulb go less brightly.
Okay, so the brightness of the bulb depends on the electricity that flows through it. If it is stronger, the light bulb will be brighter. But if the current is low, it will glow less brightly. So let's look at these questions. The first question is, what affects the amount of current flowing through a circuit? Second question is, will a current in a circuit change when the arrangement and number of components change? For the third question, will the current change when the power source is changed? So here is an example of a series circuit. In a series circuit, the diagram below shows 3 circuits, each with a different number of dry cells connected. So if you look at each circuit, they have different numbers of dry cell or batteries. In a series circuit, the positive terminal of one dry cell is connected to the negative terminal of another dry cell. So which one? Wait. All the bulbs used are identical. So which one do you think glows brighter or the brightest? Circuit 1, circuit 2, or circuit 3?
Circuit 3.
Okay. Why do you think circuit 3?
Hey, the circuit 3 is golden battery.
There are 3 power source or battery. Okay, here's the explanation. Who wants to read the first one?
Me,
Okay, please read.
the bulb in the circuit with 3 dry cells lights up the brightest.
Okay, thank you. Next sentence, please.
This shows that the brightness of a bulb is affected by the number of dry cells used.
Okay, who wants to read the next sentence? Yes, ready.
Me.
Who's that me? Okay, Kiki.
This is because when more dry cells are used, a large current flows through the circuit and through the bulb.
Okay, thank you. Next sentence, please. Who wants to read?
Connecting the batteries and end to end increase the current provided.
Okay. Connecting the batteries end to end increase the current provided to the circuit. So in a series circuit, the positive end of a dry cell is connected to the negative part or terminal of the other dry cell. So it will be positive, negative, negative connected to positive, negative connected to positive. So the more batteries or dry cell you use, the stronger or the larger the current will flow in a series circuit. Try to remember. Positive connected to negative terminal of the other dry cell. So can you think of some electrical devices which have batteries in series? Can you give some example? It can be 1 dry cell use, 2 dry cells, or 3 dry cells or more. Can you give example?
Huh?
Can you give one example?
What example?
Okay, I will give a flashlight. So
Oh, hey.
in a flashlight, the batteries are arranged in series like this. Series like a series circuit. So the more battery, the stronger the flashlight will glow. Next, we have parallel series. The diagram below shows 3 circuits. Each circuit has a different number of dry cells connected to the bulb. Okay,
Yeah.
here. So in parallel circuit, the positive terminal of a dry cell is connected to the positive terminal of another dry cell. So it will be positive to positive, positive to positive, and negative to negative, negative to negative. So what do you observe here? Look at their bulbs. So as you can see, they glow the same brightness. Here's the
Say
explanation.
like
Who wants to read the first one?
the bulb in our circuit are the
Me.
same, right?
Ah, wow. Wow.
Okay, start
Understand?
reading. Yeah, you can start to read. Please start reading.
The bulb in our circuit are the same brightness. This is because other than the number of dry cells, the arrangement of the dry cells also affect the brightness of the bulb.
Okay, thank you so much. Next sentence.
Me.
Okay, sure. Please read. Good day.
In this circuit, the dry cells are connected together in a ladder-like pattern.
Okay, ladder-like pattern. Next sentence.
Yeah.
Mimi.
E.
Okay, sure.
The positive ends are connected to each other and the negative ends are connected to each other.
Okay, thank you so much. And the last sentence. Who wants to read? About the others. Who wants to read? Max, do you want to read?
Yes, I do.
Yes.
Okay, sure.
Since the bulbs are of the same brightness, it means that the same amount of electric current the following through each of the circuits.
Okay. So even if the other circuits have more than one battery or dry cell, they still glow the same. So in parallel circuit, even if you have different numbers of dry cell, the glow of the light bulb will still be the same. Unlike with series circuit, if there are more dry cell, the brighter the light bulb will glow. Okay, here. Now observe the diagram below. This time, all three circuits have one dry cell, but a different number of bulbs connected to a dry cell. Okay, here. We have three kinds of circuits. We have one with only one bulb, two with only one bulb, with two bulbs, sorry. And number three, it has three bulbs. So if you can see, the bulbs glow, has the same glow. It means the electric flowing through them has the same amount. Who wants to read the first one?
The bulb
Me.
are of the same brightness.
Okay, the bulbs in these circuits are of the same brightness as well. If you want to read, you can read. Next sentence.
This shows that for parallel circuit, the amount of current flowing through each bulb is the same regardless of number of bulbs connected to the dry cell.
Okay, thank you. Next.
Parallel circuits are extremely useful in daily life. The lights and power points in our house are connected such that they are in parallel.
Okay, so in parallel circuit or parallel series circuit, even if there are different numbers of power source or bulbs, the light that it gives will still the same. So we use this in our houses. So what do you think will happen if our houses is connected through series circuit or series circuit? Yes, series circuit. What do you think will happen? So example, your bedroom has series circuit. What will happen to your bulb, to your light? Your light will be more brighter or it will be more hotter. Okay? That's why in houses, buildings, they use parallel series so that the light bulb will not overload and break or explode. So do you know why? I already explained the, the answer for this question. So let's go with electromagnetism. Do you know what is electromagnetism?
No.
Yeah, yes.
Okay, electromagnetism is uh,
Because I
making,
see the
or you can make magnet by the use of electricity. Here's the definition for electromagnetism. Who wants to read? Anyone?
Okay. Electromagnetอะไรนะ
Magnetism.
Magnetism is branch of physics that deal with the electromagnetic force that
Occurs.
Huh?
Between.
occurs between electrically charged particles.
Okay. Next sentence or next one.
The electromagnetic force is one of the four fundamental force and exhibits electromagnetic fields such as magnetic fields, electric fields, and light. It is the basic reason electrons bound to the nucleus and responsible for the complete structure of the nucleus.
Okay. So electromagnetic fields can be or can be converted into uh, light, sound. Okay, light or sound. So solenoid. I will read this one. A solenoid is a device comprised of a coil of wire, the housing, and a movable plunger. When an electrical current is introduced, a magnetic field forms around the coil which draws the plunger in. More simply, a solenoid converts electrical energy into mechanical work. So here is an example of a solenoid.
Oh,
Oh, okay. So let's go with the magnetic field produced will look similar to one shown in the diagram below. So the first one is a diagram showing the electric or the magnetic field in a solenoid. And on the right side, it is the magnetic field in a magnet. So if you can see, they're almost the same. The south pole attract. Okay, can you see? So, like a permanent magnet, the electromagnet also has a north pole and a south pole. The iron fillings will arrange themselves along the magnetic lines. Okay, here. Electromagnetic waves in a solenoid and the magnetic field in a solenoid, in a magnet are almost the same. So if we increase the number of coils of wire wound around the iron nail, increase the number of cells connected to the electromagnet, connect the dry cell in a series and not parallel. So why do you think we need to use series for electromagnet? What's the difference between series and parallel? Okay, in a series, the more dry cell connected, the larger the current will flow. While in parallel, even if you have more dry cell or power source, if it's connected in parallel series, the same electric current will flow, not like in series. The more you connect, the larger the current will flow. So the strength of an electromagnet depends on the amount of electric current flowing through it, the number of coils of wire. So the larger amount of current and the greater number of coils, the stronger the electromagnet is. Electromagnets are extremely useful. For example, large electromagnets are used in scrap yards to lift cars. Electromagnets are also used in some door locks. So if you want to try to make an electromagnet, you can. You can use copper coil, iron nail, and a battery. In your book, you can find there an example of electromagnet. You can try to do it if you want. Okay, so that's all for lesson. Do you have any questions? Do you have
No.
questions?
No.
No. So that's all for today, and I'll see you again next time. Goodbye.
Bye.
Don't forget to
Bye.
leave your message in chat.
Okay.
I leave it already.
Okay. Goodbye. Goodbye.